Hi everyone, welcome back to example 2. Example 2 is a past paper question being extracted from 2019 HSC question 15C. So let's see what's the question asking. Part C1 asks you to show that the integration from 0 to 1 x over x plus 1 squared dx is ln 2 minus 1 over 2. I think for the first part is not too difficult because we just simply utilize one technique, which is called U substitution. U substitution. So we put U as the denominator x plus 1, and that's why du will be dx. And therefore we can change the boundary as well. When x is 1, then the u is 2. When the x is 0, the u will be 1. And that's why you can see if we use the u substitution, we can change the integration from 0 to 1, x over x plus 1 square dx, to integration from 1 to 2, and then x is u minus 1, and then the denominator is just u squared du. And this one is just simply integration from 1 to 2, and then we split the denominator, so which is 1 over u minus 1 over u squared du. So if you still remember, this is just simply what? This is just simply ln u, and then this is just simply plus 1 over u. Because like this guy is just simply you're integrating u negative 2 du. So we just simply use power rule. And then this one is just simply integrating from 1 to 2, and that's why just by simple substitution, this is ln 2 plus 1 over 2 minus ln 1 plus 1. Ln 1 is 0, and that's why the final answer is just ln 2 minus 1 over 2. So that's the first part 1. 2 marks. Shouldn't be too hard. Part C2. Part C2 said, let In be the integration from 0 to 1 xn over x plus 1 squared dx, and asked you to show that the In is 1 over 2 bracket n minus 1 minus n over n plus minus 1, and then In minus 1. So that means like is a very standard recurrence question again. So we have to kind of like correlate In and In minus 1. And if you have look at my first video of the example 1, then probably you will notice that you have to use by part here. You have to use integration by part in part 2. By part. So let me demonstrate for part 2 then. Part 2, we'll do it here. So part 2. So now the In is integration from 0 to 1, and then xn over x plus 1 squared dx. So that means like we will put u as what? We will put u as the numerator. So that means like it will be xn. So du will be just simply power rule n minus 1 dx. So that means like dv will be our 1 over x plus 1 squared dx. So that means like v will be integration of 1 over x plus 1 squared dx. So here, if you are familiar with the integration rule, so that means like this one is negative 1 over x plus 1. Then integration by part formula will be in equals like uv minus integration v du. U in this case will be xn, and then what is the v? The v is negative 1 over x plus 1, close bracket, integration from 0 to 1, minus integration from 0 to 1, and then v negative 1 over x plus 1 du, which is nx n minus 1 dx. So far so good, right? If I do some simplification for the first part is just simply negative xn, and then over x plus 1, and then integration from 0 to 1. I'm sorry, not integration, but just substituting from 0 to 1. And for the second part is, if I highlight it for you, so this is negative, negative, so that means that it is positive, positive, and then take out the n as the constant, and then integration from 0 to 1, xn minus 1 over x plus 1 dx. Okay, so, and after that, what should we do? So a lot of students get stuck in this step in that particular year, but if you still remember, like, what is the question asking for? The question is asking for in, and then I want to have something like in minus 1, right? And if you go back to what is in, let me highlight in green, the denominator got square, okay, something square. But at this stage, the denominator that we have is power 1, okay, power 1. So that means like the next step is pretty obvious. The next step is we have to multiply something to both the numerator and denominator. So that means like, let's say if the first part I do the substitution first, this one will be negative 1/2 and then minus 0, and then plus n, integration from 0 to 1, and then x plus 1, x n minus 1, and the numerator will be x n minus 1. So I would just try to change the denominator to square. That means I have to multiply x plus 1 to the numerator to balance it. And that's why this is just simply negative 1 over 2, and then plus n. So now I have to do the distribution. Distribution is like this way. I distribute the xn minus 1 to x. I distribute the xn minus 1 to 1. So that means like here will be integration from 0 to 1. So xn minus 1 times x, because like x is to the power of 1. So that means like this part is just simply xn, and then over x plus 1 squared, and then plus, this is just simply xn minus 1 over x plus 1 squared dx. So that means that if I put everything in a clearer manner, will be a square bracket. And then, so this part will be our in, and this part will be our in minus 1, right? So that means that I can rearrange the term as in, this is negative 1 over 2 plus n, and then this is in plus in minus 1. So the remaining task will be just simply I need to move the in as a subject. So that means like I would do the distribution on the right hand side, which is plus n in, and then plus n in minus 1. Then I will move all the terms that containing in on one side without the in on another side. So that means that will be just 1/2 minus n minus 1 equals like n minus in. And that's why I will just simply have 1/2 minus n minus 1, take out the n minus 1 in. Then what is in? In is just simply 1 over 2 n minus 1 minus n over n minus 1 in minus 1. Then we are done for the part 2. Shouldn't be too hard, right? For the part 2. Finally, for part 3, what are we going to do? We have to evaluate I3. Okay, so if we need to utilize what we have found in part 2 to evaluate I3, then let me try to write it down. What is the part 2 result? From part 2, we know that, so let me just copy it once again. So 1 over 2, this is n minus 1 minus n over n minus 1 in minus 1. This is the result that we have found in part 2. So that means that if I want to find I3, so basically I need to find 1 over, this is 3 minus 1 is 2. So 2, this is just 4. And then minus, this is 3 over 2, I2. So if I need to find I2, that means that I need to find 1 over 2, and then minus 2 over 1, so it means 2 I1. Then what is I1? I1 is basically, I1 is basically just, the one that we have found in part I, you can see, because like here is when the n is 1. So that means that when the n is 1, then ln 2 minus half. Ln 2 minus half. Okay, and then I can do some backward deduction. So that means that I further substitute the I1 back to the I2. So I2 will be just simply 1/2 minus 2. I1 is ln 2 minus 1/2. So that means like I2 is just simply 1/2 minus 2 ln 2 plus 1. So that means like I2 is just simply I2 is just simply 3 over 2 minus 2 ln 2. Then I can further substitute the I2 back to the I3 equation. I3 is just simply 1 over 4 minus 3 over 2 I2, which is 3 over 2 minus 2 ln 2. And then if I do some simplification, this is 1 over 4 minus 9 over 4 plus 3 ln 2. Then 1 over 4 minus 9 over 4 is just simply negative 8 over 4, which is negative 2. So that means that I3, the final answer is 3 ln 2 minus 2. Done. Okay, so this is the demonstration of the past paper of question 15C in 2019. So if you have any questions or comment, feel free to leave it below in the comment section. So I will see you next time for the example 3 and 4. Bye bye.